So today we are going to solve the leftover portion of ISS paper 1 for the year 2022, that is the latest paper of ISS. So already I have solved two, three or four questions last time. So I will choose randomly. I have already chosen few of the question and decided to solve those questions today. So I will proceed as per my selection of questions today. Okay. So I will start with question number with the end of the paper, and let me go to the end of the paper. Okay, let's start with question number 48. Okay, the question number 48. So the question says that we have a beta distribution of first kind, and with parameter m and n is given, and the mean of the distribution is given to be one third, and the variance is 2 by 63. We need to find the value of m and n. Okay, so first we need to know that we have two kind of beta distributions, and first kind of beta distribution ranges from 0 to 1, and the second kind of beta distribution ranges from 0 to infinity. So let us start and write the PDF of the first kind of beta distribution. The PDF of first kind of beta, I am taking the distribution parameter as mn as per the question, is f of x with parameter mn is 1 by beta mn x to the power m minus 1, 1 minus x to the power n minus 1, where 0 less than x less than 1, m and n both are greater than 0 and 0 otherwise. This is the PDF of the beta first kind distribution. Okay, where this is the beta function. You know that this is called the beta function. Now, what was the information given? They are saying that the mean of the distribution is basically one third, and variance of the distribution is basically 2 by 63. So if you can compute, you will find that the mean of the distribution is m by m plus n, which is given as one third. This is my equation 1, and the variance is mn by m plus n whole square into m plus n plus 1. This is equals to 2 by 63. This is my equation 2. Okay, so I would like to ask one question. Do I need to solve and show that how I have obtained this mean as m by m plus n and this variance as this, or I can proceed for solving these two things? Do you want me to show that?
Proceed, ma'am.
Okay. So I hope you will be able to solve the mean and variance. Okay, so what I am going to do over here, just I am showing you one thing from over here. I will be writing 3m is equals to m plus n, and that is going to give me 2m is equals to n. So wherever I am going to have n, this is, let me take that as equation 3. So I am going to apply equation 3 in equation 2, and that is going to give me another equation. So wherever I'm going to see n, I'm going to replace it by 2m. So that is going to give me m into 2m, m plus 2m whole square, m plus 2m plus 1, and that is equals to 2 by 63. And that finally gives me 2m square, 3m whole square, 3m plus 1 is equals to 2 by 63. The solving is very easy. 2 gets cancelled out, and here I will get m square by 9m square into 3m plus 1 is equals to 1 by 63. And m, we can cancel this m square since m is greater than 0. This is a parameter of the distribution, and we can have 63 is equals to 9 into 3m plus 1. And that is going to give me m is equals to, I'm just keeping 2 or 3 steps, and that is going to give me m is equals to 2 directly. Okay, that is going to give me m equals to 2. So from equation 3, we get n equals to 2m, that is 2 into 2, that is equals to 4. So the pair of value of m comma n is basically 2 comma 4. So let's check out the options. Yes, this is the correct option. Is it clear?
Yes, ma'am.
Okay. Next, going for another sum. Let's go for question number question number 52. Okay. What they are saying that xi is a set of IID random variables, I running from 1 to n. So their CDF is defined by capital Fx, PDF is defined by small fx. So the PDF GZX, this is GZX. I'm just rewriting it for your like easy for easy communication. GZX, where what is my Z is nothing but x order 1. So they have defined x order 1 as minimum of xi, 1 less than equals to I less than equals to n. This was my notation, and we have to find the PDF of this. So let me brief out the question a little bit. This is my question number 52. So they say that x1, x2, xn is a IID random sample. They have CDF capital Fx, and they have PDF small fx. Okay, let us define this. Okay, let me define something else as well. Let me define this x order 1 less than equals to x order 2 less than equals to less than equals to x order n be the n order statistics, or I can write n ordered samples, n ordered random samples. In ordered random samples, I have with me this thing, and I am defining Z to be the minimum of this x1, x2, xn. So that is basically x order 1, and another notation for this is minimum of this n of xi. Okay, and that is my xn. So I need to find what I have to find, PDF of Z. What is this? This is what I have to find. This is purely a theory question, basically a theorem type of thing, what you have to prove. So let us try this out. So we have taken Z to be X order 1. And before I start the question, I would like to draw a small graph for my easy explanation. This is my x order 1. This is my x order n. After ordering the random variables, this will come. So the random variable first coming in my set will be x order 1. The last one will be x order n. And all other random variables will lie between x order n. Since we So x order will in between two lies between these two. So now start proceeding for finding capital F of Z. That is the CDF of what is this thing? This thing is basically CDF of Z. Okay, so that is going to give me probability capital Z less than equals to small z. So in place of capital Z, let me replace x order 1 less than equals to some small z. Okay, so now let us concentrate on this particular graph. Okay, let me extend the left side a little bit. Right side is already extended. Now, what will be the all possible position of this particular value? This capital X order 1 is replaced in the place of capital Z. So, it is a random variable. This is a random variable, no doubt. But this is a particular value taken by a random variable. This is a value taken by a random variable. So this is not actually a random variable, it is numeric. So where can actually it lie? Any value taken by these two random variables have three chances of lying. Either it will lie on the left side of x order 1, either it will lie on the right side of x order n, or it will lie between x order 1 and x order n. So they have clearly said that it is less than or equals to x order 1. So obviously the one place where it can lie is this region, less than or equals to x order 1. So here this is the place where z can actually lie. So if the random variable lies over in this region, I am extending this red line a little bit more. So if the random variable lies over here, actually in this portion, z may be over here, maybe over here, anywhere, but it should be in the left side of x order 1. So wherever is my z, so if it is less than x order 1, obviously it is going to be less than all of the random variables because it actually satisfies this particular inequality. So that means what? If this variable is less than the minimum value of the random variable, so obviously it is going to be less than all the other random variables which are greater than the minimum itself. Yes or no? Oh, sorry, I just mistakenly wrote one line. It is not less than equals to, it is greater than equals to z. Sorry. So z may lie on the right side of this. This will be the region. Sorry. So if so basically it is greater than x order 1. So this is not the case. So it is basically greater than x order 1. So if it is greater than x order 1, so it may lie anywhere on this right side, here, 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 or maybe here. So it may be between x order 1 and x order n and may be greater than x order n as well. So we can't detect its exact position. If it is less than x order 1, then we could have detected the position very easily. That is in this green zone. If it is in the green zone, then we could have detected the position easily, but it is not in the green zone, it is in the black zone. So it's very difficult to detect the position of this Z. So what we are basically doing over here, we are actually taking the reverse or the complement set of this probability. This x order 1 is greater than actually Z. So if x order 1 is greater than z, then basically z will actually lie in the complement set, and instead of lying in the black zone, it will come in this particular blue zone. This blue zone, or which is overlapping with the green zone. So that is if any of the x order 1 is greater than z, so that means 1 minus basically probability of any of the x1 greater than z, any of the probability of x2 greater than z, and so on, any of the probability of xn greater than z. And since they are random samples and also they are IID, that means they are identical. If you wish, you can actually skip this particular step. So that is probability of x1 greater than z whole to the power n. So this is the step which we you have obtained. So basically this is what we are getting. This is the CDF. So probability capital Z less than equals to small z is equals to 1 minus probability x order 1 greater than z whole to the power n. Now we will find the PDF. PDF is small f of z. They have defined it to be GZ, which is DDZ of FZ. Or instead of giving the FZ, I should have given the name capital GZ to keep a parity with the PDF. That will be helpful. So it is GZ. So it is 0 minus n into probability. So we can take a minus of this thing as well. So we will write 1 minus probability x1 greater than z whole to the power n. So let me change this step. So that is going to give me 0 minus and again 1, again 0 minus n into probability x1 greater than equals to z. So we will proceed and ultimately we can to the power n minus 1. So we will put the values and it is going to give me n into capital F of z to the power n minus 1. Let's check out the options. N into capital F of z to the power n minus 1 into fx, because we are further going to do the derivative of this particular thing. So probability, so not f of z, yes, f of z to the power n minus 1 into small fx. Let it be fx. So this is the thing. Clear? Any queries? There was a jumble up in the notation because I have used my own notation. So if you want, you can use the notation given over here. So if you want, I can just explain it in a brief little bit again. Shall I explain it again? First, tell me till this much is clear or not. Okay, I am rubbing this portion and explaining this part again to avoid the confusion. Of this Z and X confusion, I am doing this again. Till this much is clear or not? So what we have obtained, this is basically my G, Z, X. Okay. So this is the CDF of Z we have obtained. Now how to obtain the PDF? To obtain the PDF of Z, we need to do the derivative of CDF of Z, that is basically G2GZX given by the question is DDZ of GZX. Okay, so what was my GZX? This thing. And what was basically my this particular thing, this x1 x2 xn was this, and this they have defined this capital fx to be and this small fx to be the CDF and PDF already. Okay, So that means this small fx, this capital Fx will have the expression probability capital X less than equals to some small x. Okay, so what I can do, I can change this thing as d d z of 1 minus probability x1 less than equals to z. This inside portion greater than I have changed to less than. Okay, so instead of z, I can use it to be small x. So let's do this. 1 minus capital F of z whole to the power n. Because this is x1, so this is z. This is will be x. Okay, so now we can do the derivative. 0 minus n into 1 minus fx to the power n minus 1, and then it is going to give me something 0 minus small fx. So this n into 1 minus fx to the power n minus 1 into small fx. So as the confusion is cleared, sorry, I have underlined the wrong one. This is the correct answer. Is it clear now?
Yes, ma'am.
Okay, next moving on to some other question. Let's try out this one. This is pretty easy. Question number 43. What the question says, this says that we have a density function like this, ranges over the real number line, and we need to find probability minus 1 less than x less than 2. So the density is given by, yes. Okay, so as here, let me brief the definition of mod x. So mod x is equals to x if x greater than 0, is equals to minus x if x less than 0, is equals to 0 if x equals to 0. So as you can see, this is actually a PDF. So x equals to 0 is equals to 0 in continuous distribution. We don't find or we don't get the probability of a particular point, and we say that the probability of a particular point is actually 0. So we basically discard this particular case inside the definition of mod x for this particular sum. So what we are dealing with for the negative and positive range of this whole distribution. Okay, so now let us write this particular thing, probability minus 1 less than x less than 2. We are going to divide the whole region into two parts. One is minus infinity to minus 1. Basically this portion, so basically since the function is defined over the whole line, so we are not defining the whole part. We can directly write minus infinity minus 1 to 0, that is the negative portion of fx dx, plus 0 to 2 the positive portion fx dx. So in the negative portion it will be half, fx will be e to the power minus of minus x dx, and in the positive portion it will be 0 to 2 e to the power minus of plus x dx. I have deliberately written plus x just for your understanding. In the exam you can just directly do the plus minus multiplication and write it. Okay, so half into minus 1 to 0 e to the power x dx plus half into 0 to 2 e to the power minus x dx. So it's pretty easy, rest of the calculation. So e to the power x minus 1 to 0 plus half e to the power minus x minus 1 0 to 2. So you will calculate and you will see, you will get the answer like this. So it's basically equals to option number 1. Just check whether you are getting this particular answer or not. Have you got the same answer? Am I audible? Have you got the same answer?
No, ma'am, I'm not getting 2.
Not getting 2. Okay.
Yes, ma'am.
I got it.
This will be half into e to the power 0 is 1 minus e to the power minus 1 plus half. We have a minus 1 outside. E to the
Yes.
power minus 2 minus e to the power 0 is again 1. Okay. So this is not, we don't need this bracket, sorry. So let's take half common. So you will be getting 1 minus e to the power minus 1 minus, you will get e to the power minus 2 minus 1. So let's split this up. Clear?
Yes, ma'am.
Okay. Next, moving on to the next sum. So let's try out question number 47. For question number 47, basically they have given us a PDF of a random variable of this form and they have asked us to find the value of k. So it's a PDF form is a little bit complicated, but we need to find the value of k. So let me write the PDF form. Kx cubed by 1 plus 2x or to the power 6. Now x is greater than 0 and you have to find the value of k. So we know that this function will be a PDF if it satisfies the property that fx is greater than equals to 0 for all x. So this first property is satisfied. Property number 2 says that integration over the whole range of x fx dx is equals to 1. So from this property, I need to find the value of k, or what I should say that by using this property. So let us write the value of x is basically 0 to infinity k x cube by 1 plus 2x whole to the power 6. So that is 1 by k is equals to 0 to infinity k cube 1 plus 2x whole to the power 6 dx. So let's try and take our transformation. So let's take this transformation. Let's try this out. It's 2 into dx is equals to du, and the range of x and u will be, for x infinity it is going to be infinity, for x 0 it is going to be 1. So the range changes. It is 1 by k. You can proceed in your own way as well. For x cube, we will be writing x. Basically, from here we are getting u minus 1 by 2 is equals to x. So u minus 1 by 2 whole cube by u to the power 6 into, instead of dx, we will write du by 2. So let's change this again. 1 to infinity. So this is basically 1 by 2 to the power cube u minus 1 whole cube by u to the power 6 into du by 2. 2. Sorry, not 2 cube, it's du by 2. So let's change this, and 1 by k is equals to, and we can actually take this over here, 2 cube. 1 to infinity, u minus 1 whole cube is going to give me u square minus 3u plus 3u square, sorry, plus 3u minus 1. That is a cube, sorry, that is a cube minus 3a square b plus 3ab square minus b cube, okay, divided by u to the power 6 into, that is, we can write 2 to the power 4, and that is du. Now it's pretty easy to compute this. 2 to the power 4 by k is equals to 1 to infinity u cube by u to the power 6 du plus 1 to infinity, sorry, it's not plus, it will be minus 3u square by u to the power 6 du plus 1 to infinity 3u by u to the power 6 du minus 1 to infinity du by u to the power 6. So let's proceed and do the rest of the part. 2 to the power 4 by k is equals to, that is going to give me 1 to infinity 1 by u cube minus 3 1 to infinity du by u to the power 4 plus 3 1 to infinity 1 by u to the power 4 and minus 1 to infinity du by u to the power 6. So basically these two functions are same, ranges are same. So these two will cancel out, and we are left with these two, that is 1 to infinity u to the power minus 3 du minus 1 to infinity u to the power minus 6 du, that is giving us u to the power minus 3. So we know integration of x squared dx gives me x cubed by 3, that is basically x to the power 2 plus 1 by 2 plus 1. So this is minus 3 plus 1 by minus 3 plus 1, 1 to infinity, minus u to the power minus 6 plus 1 by minus 6 plus 1, 1 to infinity. So let's compute this in details. So that is going to give me, okay, let's write this over here, minus 2 and u to the power minus 2, 1 to infinity, minus u to the power minus 5 by minus 5, 1 to infinity. So let's write this, minus half is over here, 1 by u square, 1 to infinity, and you will write 1 by 1 by 5 and 1 by u to the power 5, 1, 1 to infinity. So basically that is going to give me 1 by 5, 1 by infinity is 0 minus 1 minus half of minus half of 1 by infinity is 0 minus 1. So that is giving me, sorry, that is giving me basically 1 by 5 minus 1 by 5 plus half. So that is half minus 1 by 5, that is going to give me 10, 5 minus 2 is 3 by 10. So we basically have 2 to the power 4 by k is equals to 3 by 10. That implies 3k is equals to 2 to the power 4 into 10, and that implies k equals to 2 to the power 4 into 10 by 3, and you need to solve this and you will get the value of k among these values. Is it clear?
Yes, ma'am.
Just check for once the calculation. If there is any calculation error, you just fix this up. Okay.
There is no option, ma'am.
Check the calculation once.
Okay.
Let me check it as well. You check it once, I am checking it as well. Have you found any error in my calculation? Yeah, there is one error. This is 6 minus 1, that is going to be minus 5. So it won't get cancelled out. It's not that easy. So you need to add this up, minus 3 into u to the power minus, okay, let me add this, du by u to the power 4 plus 3, 1 to infinity du by u to the power 5. So let's add this term with this, minus 3 into u to the power minus 4 plus 1 by minus 4 plus 1, 1 to infinity plus 3 u to the power minus 5 plus 1 by minus 5 plus 1, 1 to infinity. minus 3, and it gives me 1. This minus 3, this minus gives you plus, 3 cancels out, 1 by u cube from 1 to infinity, plus minus this 3 by 4, let me write this as minus again, minus 3 by 4, and this 1 by u to the power 4, which is going to give me 1 to infinity. So write this, plus 1 by infinity is 0, minus 1, minus 3 by 4 is 0, minus 1. So that is going to give me, so we can change it from over here. So that is going to give me minus 1 by 5 plus half, and that thing basically give me 0 minus 1. So basically it is minus 1, and this particular portion gives me plus 3 by 4. So can you calculate this and tell me what will be the value? This is half plus 3 by 4 minus 1 plus 1 by 5. If I am not wrong in the signs. Plus minus, if I am not getting confused in the sign, then it is correct. So that is going to give me 5 by 4 minus 6 by 5. That is 1 by 20. So basically it is giving me 1 by 20. So this thing, is it matching now?
Yes, ma'am.
It's I think 320, right? We have a value 320. Yes. There was a mistake in the calculation. That's why it's not matching. Is it okay now?
Yes, ma'am.
Yes, ma'am.
Okay. Let's go and try out question number 54. Okay. So this is not a question which you have to calculate anything. This is a question where you have to just see it and just have to observe and have to tell me the case. Okay. So here you have to detect the cases which under which kind of testing it is actually coming. Okay. So they have asked you to test for the sigma for the univariate normal, as you can see, and normal 0 sigma square is giving, and they have asked that which will is going to be the appropriate test, that T, F, chi-square and normal. So now how do you classify this problem and how do you remember that? So that I am going to tell you in brief. Let me discuss the univariate cases today only, because I don't have enough time to discuss the bivariate, not bivariate, sorry, two univariate cases today. So suppose we have, this is what the question number, I think it's 54, I told you, right? Let me check it. Yes, it's 54. So suppose we have x1, x2, xn is a IRD sample from some normal mu sigma square. Okay, so this is the case which we are doing. So basically we will have testing of two kinds of parameter, one for the testing of mean and one of the testing of variance. For if we go for testing of mu, so this is basically based on univariate normal, based on one univariate normal distribution. Okay, so this is based on one univariate normal distribution. If we have test for mu, we basically have two cases where sigma is known and where sigma is unknown. And on another side, we have testing of sigma, where again we have two cases where mu is known, where mu is unknown. Okay, so basically now how do we classify our problem? So as per the problem, the test will actually going to change. Okay, so basically if we can just briefly tell, so basically for this test where testing of mu where sigma is known, we use normal. For this we use t-test. For this we use chi-square with dfn, and here we use chi-square with df n minus 1. Okay, so how do we classify our problem basically? So they says that we have to test this, that is test for sigma. So first, whenever we are going to see the scenario, first we are going to judge it is based on a single univariate or not. Let's see, yes, it is based on single univariate. Now we have to test this h naught sigma square is equals to some sigma naught square. So we have to test for sigma, that is if it comes under this category. So under this category, which subcategory we are going to choose, mu known or mu unknown? That is going to depend on chi-square test. So here, since the option has only chi-square test, degrees of freedom is not given. So without seeing that, you can actually tick on chi-square test and your answer will be correct. But just for in case, if you have more than one option with chi-square test and the degrees of freedom is specified, suppose you have another option E that gives you chi-square test with degrees of freedom n minus 1, and this option instead of chi-square you have chi-square with degrees of freedom n. So you don't get confused between these two. So sort of this kind of problem, so you see that what this actually follows, this follows a normal distribution with this. What is this information is required? Here it is actually not required. I won't say it is not required, it is helping you to detect whether it is a univariate normal or it is a two univariate normal. Yes, it is one single univariate normal. Not only that, the mean is actually fixed at 0. That means the mean is known. So this mu is known. We are actually concentrating on this part, and this is giving me a chi-square distribution with degrees of freedom n. So without any like hesitation, we can tick on this chi-square test. No F test, no normal test, no test will T test will be applicable over here. Is it clear?
Yes, ma'am.
Any queries, anyone?
No, ma'am.